I'm Elena May, and I'm part of Challenge 2016. For this video, interactive learning assignment number 3, I'm going to be explaining how we evaluate the integral from 0 to infinity of 2e to the negative theta sine delta theta. Now, the problem already says that it converges, and what we have to do is find where it converges to. So what the first step is going to be is we're going to move the constant outside the integral. So this now becomes 2, the integral of 0 to infinity, e to the negative theta, sine theta, delta theta. Now, once we put this 2 in front of the integral sign, we can now see it's an integration by parts problem. So we're going to set our u equal to e to the negative theta, and our dv is going to equal sine theta. We know our du will be negative e to the negative theta, and v will equal negative cosine of theta. So now we rewrite this as 2 d times v, e to the negative theta, I'm going to put another one right here, times cosine theta, minus the integral from 0 to theta of v, negative cosine theta, times du, negative e to the negative theta, d theta. Now what we have to do, let me put a bracket sign right here. So now we see that this is another integration by parts problem. We're going to set our u equal to negative e, or actually, first what we're going to do is we're going to simplify this to account for all the negatives. So this becomes 2 e to the negative theta cosine theta minus the integral of 0 to theta. We're going to get negative times negative is positive, but there's this negative right here, so it's a negative. So cosine theta e to the theta, negative theta, d theta. All right, now we're going to integrate by parts. U is equal to e to the negative theta. Now when you're doing integration by parts twice, you want to make sure that you keep your u's the same. If you don't do that, then you're going to put yourself in a loop and you're just going to get back to this step and it's just going to cycle through it. That's not good. So u is equal to e to the negative theta, dv is equal to cosine theta. So our du is equal to negative e to the negative theta, and v is equal to sine theta. Now from this step, it's going to get a little messy. We see it's going to equal 2 negative e to the negative theta cosine theta minus, now we need to put more brackets here, u times v, so e to the negative theta times sine theta minus the integral from 0 to theta, or to infinity, du times v, negative e to the negative theta times sine of theta, d theta. And we'll put one more right there. Now what we're going to do from that step is we're just going to simplify this mess. So from there, we're going to say it's equal to 2 negative e to the negative theta cosine theta minus e to the negative theta sine theta minus the integral of negative e to the negative theta sine theta d theta. All right, one more step. Let's put a 0 to infinity there. And we're going to keep going. So this is now equal to, it's just a lot of simplifying going on right now. 2 negative e to negative theta cosine theta minus e to the negative theta sine theta minus negative the integral from 0 to theta, or the integral from 0 to infinity times e to the negative theta sine theta d theta. Alright, now from here we can see that this part is equal to what we wrote right here. And that's really important for us to notice. So I'm going to put a star here so we see that. So what we're going to do is we're going to add this back to this. So this now becomes, or we see that 2, the integral from 0 to infinity sine theta e to the negative theta d theta is equal to 2, whoop, that should just be a theta right there, sorry. Negative e to the negative theta sine theta minus e to the negative theta cosine theta minus, let me rewrite that, cosine theta minus the integral from 0 to infinity of e to the negative theta sine theta d theta. There should be a theta right there. Sorry. So we're going to isolate this integral from 0 to infinity of sine theta e to the negative theta. And what we get from there is 2 times negative 1/2 e to the negative theta sine theta plus cosine theta, which is, we can cross this out, and it's equal to e to the negative theta times sine theta plus cosine theta. Alright, so now that we have that step, we have to integrate, or we have to evaluate at 0 and infinity. So I'm going to just move the camera over a little bit. We're ready to do that. So first, limit as x approaches 0 from the right side, and that is equal to negative e to the negative 0 sine of 0 plus cosine of 0, and that is equal to negative 1. Now we're going to the limit as x approaches infinity, negative e to negative infinity, sine of infinity plus cosine of infinity, and that is equal to 0. So we have 0 minus negative 1, and that is equal to positive 1. So we find that the integral of 0 to infinity, 2e to the negative theta sine theta d theta, it evaluates at 1. And that's how you solve that problem.